Welcome to class of physics. In previous lectures, we have studied about linear momentum, conservation of linear momentum, and the equation of rocket. So these all are studied under the linear momentums. Now we are going to study the angular momentum and law of conservation of angular momentum. Okay. First, angular momentum. The angular momentum of a particle about a point is the moment of linear momentum about that point. Okay. So here the important part is moment of its linear momentum about its point, that we call it as angular momentum. Okay. Linear momentum means the amount of motion present in the body. In mathematics, we can define linear momentum as product of mass and its velocity. Here the angular momentum is moment of its linear momentum about that point. It is also called moment of momentum. It is also called moment of momentum, and it is denoted by letter Z. Here the arrow mark indicates it is a vector quantity. It is measured by the product of linear momentum of the particle and its vector distance r from fixed reference point. The linear momentum is given by the product of mass and its velocity. That is, linear momentum is what? P equal to product of mass and velocity. But angular momentum is represented by J, so it is the product of linear momentum and its position vector r. Okay, so here cross product is there. It is a product of linear momentum and its position vector. So in linear momentum, mass is scalar quantity, whether velocity is vector quantity. But here both are vector quantities, the linear momentum and the position vector. And mathematically we can write this as Z equal to M into R cross P. Why you are writing like this? Here Z equal to what? Right, it is as R cross P bar. Okay, so then R bar cross product of what is P? It is product of mass and velocity here. Okay, then it is P bar. So here mass is scalar quantity, then we can write it as M R cross P. Okay, so this is position vector. It is a vector quantity and its direction is perpendicular to both r and p or velocity v. The direction of the angular momentum is perpendicular to the position vector or the momentum vector or in terms of velocity. SI unit is kg meter square per second. The SI unit of angular momentum is kg meter square per second. The dimensional formula we can write it as ml square t power minus 1. So this is all about angular momentum. The definition involves moment of its linear momentum, or we can call it as moment of the momentum, denoted by vector j, and mathematically we can write it as the product of linear momentum and its vector distance. So j equal to m into r plus p, and its direction is perpendicular to r and p. And SI unit is kg meter square per second. Dimensional formula is ml square t power minus 1. Next, torque. Okay, what about the torque? Here force is responsible for linear accelerations while torque is for angular accelerations. If a particle is moving in a linear motion or in straight directions, so that is because of the force. Okay, here torque means a force which is required for angular acceleration. If a particle moving in a circular path, then it has angular acceleration. So here that force we call it as torque. Torque is nothing but it is a force. Torque is a vector product of position vector and force. So here the torque is what? It is vector product of position vector and force. Okay, so position vector is what? Position vector is r and force is F. Okay, so vector product is there, for that it is cross product. So R cross F is torque. If F force acting on a particle at a point P whose position with respect to origin of the inertial frame is given by the displacement vector r1, then the torque on the particle with respect to the origin O is defined as tau equal to R cross F. This is the expression for torque R cross F. Okay. Here a particle is moving in a circular path. Here this indicates its position vector R. Then there is a force is acting on this. It has angular acceleration. Now whatever the force is here, so that we call it as torque. Torque is a vector quantity. Its direction is normal to the plane formed by the R and F. Okay, so torque is perpendicular to the plane formed by vector position and the force. Unit of torque is Newton meter. Force having unit Newton, position vector is that unit is measured in meter, so that the unit of torque is Newton meter. So this is the definition of torque. Now we are going to relate the torque and the angular momentum. What is the relation between torque and angular momentum? That means we are going to write the equation of torque in terms of angular momentum. Okay, so angular momentum is here z equal to r cross p. This is a vector product of position vector and the linear momentum. For that, z equal to r cross p. And what is p? P is mv. That just I explained that one, so that we can write angular momentum as m into r cross p. Now differentiate with respect to t. When you are going to differentiate this above equation with respect to t, then we can write this as dz by dt equal to m into, so here m is constant, for that we no need to differentiate this one, d by dt of r cross p. So carefully differentiate this one, because here we are going to differentiate cross product of two vectors, so that here I am going to differentiating this one, dr by dt. Okay, so first differentiate this part, dr by dt into the remaining as it is, m into p, plus now keep this r as it is, differentiate this another term. Okay, so r into t by dt of, just like uv term, product differentiation of product of two variables. Okay, now so dr by dt is what? It is first derivative of positions, that we call it as velocity. For that, dr by dt becomes v, and the remaining is m into v. Okay, so don't call this as into, call this as cross product or vector products. Okay, if you call this as into, then the term becomes different, plus r cross product of d by dt m v as it is. Now these two are cross products, then we can write this as m into v cross p, plus r cross product of d by dt of mv. Then here v cross p. Okay, so this value is 0. Don't write this as v square. It is a vector product is there. For that, the value of v cross p is 0. This term is vanishes. That becomes equal to 0. The remaining is only r cross product of d by dt of mv. Okay, here I am writing it. What is d by dt of me? D by dt of me means me is what? It is p. Okay, d by dt of mv is p. According to Newton's laws of motions, the rate of change of momentum. Okay, dp by dt means it is what? Rate of change of momentum, that is equal to force. Now this term is replaced by f. So finally dz by dt equal to what? R cross product of f, that is r cross f. Okay, comes here for definition of torque. Okay, here there is a equation is there, torque equal to what? R cross f. For that, now replace this r cross f by tau. Okay, it is tau. then we can write tau equal to dz by dt, but r cross f is the torque acting on the particle, so that tau equal to dz by dt. Now we are going to relate these two equations. Here torque is there, here angular momentum is there. Finally torque is acting on a particle is the rate of change of angular, not it is velocity, it is angular momentum. Okay. Rate of change of angular momentum. Okay. So this is the relation between torque and angular momentum. Now we are going to study the conservation of angular momentum. So that is also same like this. Okay, whatever here we derived a small derivations, so this only will give about law of conservation of angular momentum. Law of conservation of angular momentum is the same derivations, just taking one more step only. Law of conservation of angular momentum states that when the total external torque acting on a system of particle is 0, the total angular momentum of the system remains constant. Simple. If external force acting on a system is 0, then the angular momentum remains constant. Hence we call it as conservation of angular momentum. For law of conservation of linear momentum, if the external force is 0, then that we say that the linear momentum is conserved. Here the force is nothing but it is a torque in case of angular accelerations, so that if the external torque acting on a system of particle is 0, then the total angular momentum of the system remains constant. Sure, the angular momentum of particle about a point O is given by just previously I derived. Okay, I draw an diagram here. Okay, so it is R, it is O, there is a point P is there, it is a origin and it is position. A particle about a point is given by z equal to r cross p, same again. Okay, so z equal to what is p, it is mu, so that we can r cross p, then differentiate dz by dt equal to d by dt r cross p. Okay, remaining all are same steps, p cross p. So here p cross p is 0, then this vanishes, it becomes 0, the only is second term is left. Then d by dt mu is what, it is force. Where r is the radius vector of the particle about a point O and p is the moment of force or torque about that point is given by tau equal to r cross f. Now tau equal to what, it is r cross f, replace this r cross f. Okay, then dz by dt equal to tau. If tau is 0, that means if torque is 0, this term is 0. Okay, tau is equal to 0, then what becomes, dz by dt equal to 0. Okay, so here a first order derivative is there of angular momentum z. So if it is equal to 0, then what it indicates, this is a constant term, not a variable. Now it is a constant. If first derivative is 0, then that whatever we are going to differentiate, so that indicates it is a constant, so that z equal to constant. If z equal to constant means what, it is a law of conservation of angular momentum. This is the principle of law of conservation of angular momentum. Okay, here some examples are mentioned of this where the angular momentum is conserved. Okay, so here planetary motion or satellite motion, angular acceleration containing contraction, scattering of protons or alpha particles by heavy nucleus. In all these examples, the angular momentum is conserved. Okay, so this is all about the angular momentum and conservation of angular momentum. In further classes, we are going to study about principle of work energy theorem. Okay, thank you.